Hey guys, this is my video review of pages 33 through 35 in your Unit 2 packet, the compound mixture element scenarios. I'm going to move through this pretty quickly because I have a 15-minute max here for this website. Alright, so for scenario 1, it says a colorless homogeneous substance that is liquid at room temperature is heated in a beaker. The liquid starts to bubble and the amount of liquid slowly diminishes. After 20 minutes, the beaker is entirely empty and perfectly clean. Was a liquid in the beaker most likely an element, compound, or mixture? Explain your answer. All right, so when I read through that passage, one of the first things that struck out to me was it said the beaker is entirely empty after it evaporates. What that tells me is that is not a mixture. If I had a mixture, something like salt water, which is a solution of salt and water, the water would evaporate away, but the salt would be left behind. That would happen with any mixture, so that eliminates that as a possibility. It also tells us that this is a colorless liquid. We know from class that there are only two elements that are liquid at room temperature, that being bromine and mercury. Neither of those is colorless. Mercury is silver, and bromine is like a maroonish purple when it is a liquid. All right, so because of those two reasons, I was able to eliminate both mixture and compound, or mixture and element, leaving me with the correct answer as compound. This process of elimination is a good way to go through these scenarios, or at least most of them. All right, scenario number 2. And I did not put the drawings in here. You'll have to look at your page for that. But it says the drawing on page 33 shows what a substance would look like if we could see it at the atomic level. Identify the following as an element, compound, or mixture, then draw a diagram of what each of the remaining classifications would look like. So by looking at this picture, I can tell that there are more than one different types of atoms. You can see that the different circles have different colors and marks and lines in them, showing that they are different atoms or elements. So it's not an element. It's not all the same type of atom. Each of those individual molecules is each identical to the others. So that eliminates the possibility of mixture. Mixture, you would see different combinations of compounds and elements. So our answer is definitely compound. You all will have different drawings. I'm not going to go through and check everybody's, but what you can do is go to page 21. There are plenty of examples of pictures of both mixtures and elements that you could draw as well. Just because your friend has a different picture doesn't mean you were wrong. Scenario 3 says a substance consists of carbon, hydrogen, oxygen, and silicon. Is this substance most likely an element, compound, or mixture? Explain your answer. So right in the question it says it consists of carbon, hydrogen, oxygen, and silicon. That eliminates the possibility for this to be an element. There is more than one type of element present, so it cannot be that. Sadly, there is not enough information to tell us whether this would be a compound or a mixture. If these substances, the carbon, hydrogen, oxygen, and silicon, were chemically bonded together and chemically combined, then that would make this a compound. While if these things were just physically mixed together and put in a jar, that would make it a mixture. Okay, the big difference here is compounds are chemically bonded together. Scenario 4. A liquid with a yellowish appearance is poured through filter paper. The liquid that drips through ends up being colorless, while a yellow powder collects on the filter paper. Was the liquid in the beaker most likely an element, compound, or mixture? Explain your answer. All right, so for this process, we have a container that has a yellowish liquid, pour it through the filter, right? And then it's asking, was that original liquid in that beaker, that yellowish liquid, an element, compound, or mixture? So when it says it has a yellowish appearance, I knew it's not an element, right? Because we said before there's only two elements that are liquid at room temperature, bromine and mercury, and neither of them is yellow. Because this liquid separates when we pour it through the filter, right? The clear liquid passes through, but the yellow powder stays. I know it cannot be a compound because all compounds would be able to pass through a filter paper without being separated. we need to use methods of chemical separation, something like electrolysis, to separate a compound. So that makes this a mixture. Now you can even go one step further. You can actually tell that this is a suspension because both solutions and colloids, there's a typo down here you can see. It should say both solutions and colloids have solute particles small enough to pass through the filter paper. So if we did something like salt water, and we pour that is a solution, we pour that through a filter paper, all of it will pass through, including the salt. If we had something like milk, milk would not separate, even though it is a colloid, it would all pass through the filter paper. It would have to be something with larger particles that can get stuck, particles that are bigger than the holes in the filter paper. Scenario 5A. So scenario 5 had two parts. I broke it into two slides. A 45.2 gram sample of fool's gold is heated strongly and results in the formation of iron and sulfur. The fool's gold was not magnetic. So we did not have enough background information to completely answer this. We did talk a little bit about, and I think we watched a video of the difference between a mixture of iron and sulfur and a compound of iron and sulfur. But if you had to use the internet to research this, that is fine. So in this experiment, is fool's gold an element, mixture, or compound? Explain how you know. Well, right away we know, because it says it's the formation of iron and sulfur, it cannot be an element because there are more than two different types of elements present in this substance. If you did further research, you might have seen that fool's gold, which is actually the mineral pyrite, is a compound. It has a chemical formula of FeS2. There are two sulfurs for every one iron present. They're chemically combined together, and we chemically separate it by heating. Now, heating is not always going to tell you whether something is a compound or a mixture. You can heat up like metal ores to separate them, and that is a physical separation. But in this case, it would be a chemical separation because we are chemically breaking the bonds of the iron and the sulfur. So that is a compound. Please do not stress over this one. This is not, 5A is not super important. We should be familiar with methods of chemical and physical separation, but being able to specifically know what happens with iron and sulfur is not something that you need to focus on. All right, 5B is quite important, and if we were to have a typical Unit 2 test, you would see a question similar to this. It says, if 21.0 grams of iron is produced, what mass of sulfur is produced? Explain what you did to get your answer, and explain how you know that doing this will give you the correct one. All right, so if I have 21 grams of iron, right, it's going to be added with some other amount of mass of sulfur be produced from our total compound, which had a mass of 45.2 grams. We're going to be using the law of conservation of mass, and this tells us that matter cannot be created or destroyed, which means, just like in algebra class, whatever is on the reactant side or the left side of the arrow is going to be equal to what's on the right side or the product side of the arrow. So if on one side I have 45.2 grams of iron sulfide or fool's gold, I will have to subtract my other product, my 21.0 grams of iron. So just like a simple formula, I can do 45.2 grams of my product minus 21.0 grams of my reactant to see how much mass I would have of my other reactant. There is a similar question that we talked about recently about a campfire. So if you have 20 pounds of firewood and you burn it all, and at the end there's only 1 pound of ash remaining, well, where did that other 24 pounds go? It doesn't miraculously disappear because mass cannot be created or destroyed. The other 24 pounds from the campfire was released in the form of smoke. Right, moving on to scenario 6. A solid metallic element is heated strongly in a flame. After a few seconds, the metal begins to glow as if on fire. The metal is pulled out of the flame but continues to glow brightly for 15 more seconds. Hopefully you weren't staring at the light. I know a lot of you did. What once was a metal now has a white powdery type of appearance. Is the white powder an element, compound, or mixture? And explain. So right away you should have thought, hey, I've done this before. We did this in the chemical physical changes lab where we lit the magnesium ribbon on fire. What happens when you light anything on fire, because fire needs oxygen, it's actually that substance, in this case magnesium, chemically reacting with oxygen in the air. So what you will see, by looking at this formula, we will have our metal, or in this case I'm going to say magnesium, reacting with oxygen, and is going to produce a new substance, magnesium oxide. Now magnesium oxide has more than one type of atom or element present. It is chemically combined together, so we know that it is a compound. And the last of our scenarios. Scenario 7. You walk back in a storeroom and find 2 beakers, one containing water, the other containing a mixture of hydrogen and oxygen. Compare and contrast the contents of the 2 beakers. In what ways are they similar, and in what ways are they different? So I kind of made a little Venn diagram. So in one column I have traits of just the beaker of water. On the far right I have traits of just the beaker that contains hydrogen and oxygen. And then in the middle I put traits that both would go through. All right, so first let's talk about phases of matter. Water in this case is going to be a liquid. Actually, I might be wrong there. If it does not specify, yeah, it does not specify the phase. So this beaker of water could actually be a solid, liquid, or a gas. I'm sorry for that error. But the beaker of hydrogen and oxygen has to be a gas, because hydrogen and oxygen in their natural states are always a gas. Both beakers, and this is an obvious one, both beakers contain the elements hydrogen and oxygen, just in different forms. The beaker of water is a compound, while the beaker of the hydrogen and oxygen is a mixture. Because water is a compound, it is chemically combined, and the elements hydrogen and oxygen have gained new properties when they formed water. While the beaker of hydrogen and oxygen was just physically blended together, and the elements retain their own properties. Because here I listed this as a liquid, I wrote that it has a definite volume. That would be true if the water was in liquid or solid form. If it was in gaseous form, then it would have an indefinite volume. But because our second beaker of hydrogen and oxygen is filled with gas, it has an indefinite volume. If it was a liquid or a gas, it has an indefinite shape, and we know that both are colorless. We cannot see hydrogen and oxygen gas. We can see water, but we know it does not have a color. Hopefully this was helpful. I know going through this was quite fast. Feel free, and I highly recommend that you go through this one more time. Pause at each spot, double check the work. I tried to be quite thorough in this, and then I will be posting this PowerPoint on Canvas as well, and I will make the updated changes. So you will see that the PowerPoint on Canvas will be just a tiny bit different than the one in this video, because I did make 2 mistakes. Even though I told you I never make mistakes. All right, guys, thanks for staying on top of things. We are done our first week. Once you are done this, and we can start moving on to week 2 agenda, which I will post in Canvas. Let's see, it might be a good idea to go through and look at the CLC home experiments to see which ones you are interested in. That would be the one that will probably take more time than anything else on that list. Alrighty, enjoy your weekend. Don't go out. Stay safe.